This meteorite is basically a fossil of the solar system, except instead of bones, it's made of stardust. This is NWA 15057, and it's part of a very rare class of meteorites called CVOX 3 chondrites. As of this video, there are only 59 of those that have been identified, making them insanely rare even by meteoritic standards. So, what does CVOX 3 mean? Let's break it down. The CV is its family name, carbonaceous chondrites of the Vigorano group. These meteorites are famous for having a high abundance of CAIs, or calcium aluminum rich inclusions, and those are the very first minerals to condense from the hot solar nebula gas, making them the oldest dated solids in the entire solar system. The ox means oxidized. That tells us that the iron inside isn't shiny metal, it's actually locked up inside minerals like magnetite. That chemical fingerprint gives us a clue that its parent asteroid formed in an oxygen-rich environment, possibly influenced by water or other oxidizing processes billions of years ago. Finally, there's the 3. That's the alteration scale, and a type 3 meteorite is about as primitive as it gets. It's barely touched by heat or pressure since it formed. That means its chondrules, inclusions, and glassy bits are all still pretty well preserved, exactly as they were 4.56 billion years ago. And you can actually see those chondrules in my samples here. That's the tiny spheres that you see. Now, here's why all that matters. By comparing oxidized meteorites like this one to their more reduced cousins, scientists can map out different chemical neighborhoods in the early solar system. CVOX 3 show us what happened when planet-building material interacted with oxygen and possibly fluids, while other groups show us what the drier metal-rich regions look like. That comparison helps us test models of how the solar nebula was structured, where ice, rock, and metal sorted themselves out, and how early asteroids processed those ingredients. So really, this isn't just a typical space rock. NWA 15057 is evidence. It tells us that the early solar system wasn't uniform. It was chemically diverse, dynamic, and full of tiny worlds that experienced different fates. Studying this meteorite helps us understand not only how planets formed, but why Earth ended up the way it did. It might even help us eventually find other Earth-like planets. Want to learn more about space rocks? Make sure to like the video and give me a follow.